NKP. Find the number modulo P of directed graphs with n vertices. There is a tournament. Every pair of cities is connected, or vertices, in one way. In degree of every vertex is at most k. It is not the case that there is triangle ABCA, and then from everything to D. This is some very particular shape. I need to draw it. What is this shape? If I'm not mistaken, we cannot have this. A, B, C, and then from all of those to D. Am I right? Hi chat. I'm guessing now that without this condition, or maybe without this condition, either the problem is easy combinatorics or is just unsolvable and p-hard. So maybe this condition helps. Sometimes when the problem has multiple requirements, sometimes each of them is another part of the problem that you need to solve. And sometimes they coexist together nicely, where only together they are solvable. Here everything would be fine if there was an edge from A to C, or from C to B. So everything would be fine if we could sort A, B, C, D. If you reverse one of those edges, then A, B, C, D is sortable. It's a DAG without a cycle. I think it will be very difficult to tackle this. I don't see what to think, what to analyze. Well, in particular, we need to be able to solve the problem for k equal to n-1. So, for sure, if we remove this condition, then still the problem is solvable. So let's just try to focus on this and count graphs without such a part graph. Can you create a map? Or what kind of map? Graph G is not given. We need to count graphs satisfying this. My videos on DP helpful? Thanks, Lemma. Ask some question about programming. You can ask a question, but I will not necessarily have time to answer. Depends on the question. I prefer to discuss the problem we are talking about, of course. If there is let's try to find any triangle ABC in the graph. If such triangle doesn't exist, then the graph is good, sure. If this triangle exists, then for every other vertex D, We can't have that. But then if there is edge from D to B, then that's just another triangle. BCD, if I reverse this edge, BCD will become a triangle. F cycle of size 3. If I reverse this edge between A and D, then ABD is such triangle. And if I reverse this, I don't have a new triangle. Do I? Oh, I do get one. ACD. If I reverse only one of those edges, then I will get another triangle. I can reverse 2 edges. Or all 3 of them. If 2 of them are reversed, up, up, well, then there is ACD. If these 2 are reversed, then BDC. We will get a second triangle in all cases other than all 3 edges being reversed. If one of them is reversed or 2 of them are reversed, I claim that there will be another triangle. Alright. Then let's say that there is another triangle. Let's say that this is actually like that. And now we have here triangle DBC. It's so loud outside here. And then there are more vertices here. What happens with them? Well, we don't want all edges to come here. Here's the thing. A random graph will not satisfy this condition. In a random graph, it's just too likely that this arrangement will happen. Maybe the number of such graphs will be quite small. And maybe here, other than some special cases, we will have this domino effect that if there is a triangle, then it implies that there must be some other triangle, then there will be a lot of them, and you will be very limited in your actions when drawing the rest of the graph. That's my hope. This is impossible. Those 3 yellow edges, bad. We can't have that. So just some edges point to those 4, some edges go backwards. Is there any harm in doing this? Can I always add a vertex and just say that it has edges to everything else? Well, they cannot, then it cannot be part of any structure like that. Police? I think it was fire truck, but I'm not sure what that was. Learning C programming language since 1 year. At that point I'm stuck. Should I continue C language? What do you mean you're stuck, Joey? Like, how can you be stuck? You can, I'm sure you can learn for more than 1 year, and I'm sure there are things you don't know yet that you can get to know if you spend more time. learn Python, Java, you should read online about differences between languages to decide what you want to practice. If there are edges from something to everything else, this vertex doesn't matter. It isn't part of any forbidden structure. But if we have some edges, then that's a different story. I need to fix my tablet, drawing tablet. It's annoying to use mouse. If there is at least one edge like that, does it already imply something? Well, CDE will be... CD will most likely be a triangle unless we do it like that. But then, if we did that, then for sure this must be an edge. Otherwise we would have here a triangle and from there 3 edges to E. That's not allowed. So from E there is edge to B. And what about ABC? Well, this here we don't have any condition, so from E to A there can be either direction. If it's from E to A, then ADE becomes a special triangle. And that's basically it. If I do it like this, then did I get any new triangles? BCE. BCE. What programming site? You can watch my how to start competitive programming video. Vertices that have minimum 3 edges. Shadow Pro. We are not given a graph. We need to count graphs. Hi Suraj. This is one possible path. I can say that there is one bad triangle. By triangle I always mean cycle of size 3. Then I keep building stuff on the top of that. And always either I add an edge, a vertex from which there are edges to all those previous vertices, or I create some new triangles. Maybe exactly one. That's one possibility. The other is that we focus on a full graph already. From A there are some edges. There are edges to B, to C, to D, and there are edges from some other vertices. And what do we know? We don't know a lot. GEF cannot form a triangle. If from this group there is blue group and green group. If from blue there is an edge to anything green, like this red edge, say from B to F, then that creates a triangle. So what? Where's your pen tab? My drawing tablet is broken, sadly. Topological sort graph. This graph has cycles, so no. We cannot topologically sort this graph because it has cycles. And just so we're clear, it's not that I can generate all the graphs. If the problem was about checking if this condition is satisfied for a graph, then we would just get a graph. Here we need to be smart and we need to get some observations first. Maybe I should, in this drawing, we are looking at A and edges from A and to A. Maybe I should draw two vertices, A, B. I should say that there is some connection between them, say from A to B, and I should look at their intersection. What is price if you win Google Kickstart? You mean price with Z? $20,000? You can check. Something like that. But Gennady keeps winning for past 6 years, so it doesn't matter. That's basically Google's salary to Gennady Kortkevich. Oh, Kickstart, not Google Code Jam. Yeah, sorry, I misunderstood. Nothing. There are no prizes in Kickstart. Google Kickstart is just for fun, like Codeforces round. And that's good because then, really beginners usually can participate and fight for top spots. It's not that everybody in the world is trying to get there. That makes sense. Graph can't have cycles. It can have cycles. Why not? The only impossible thing is that it cannot have a cycle of size 3, where then from all those 3 vertices there is the same type of edge to some other 4th vertex. Any vertex with in degree at least 3 should satisfy that it lies on all cycles. Why? I don't agree. I think, Gitarin, what you're saying is that if there is some D and it has input degree of 3, then it is some hard condition about it. Well, not really, only we have a condition about those 3 vertices ABC. They cannot be a directed cycle, and that's it. I wonder if something is going on in Warsaw, because we have some high frequency of sirens now. I mean sirens. How are they called? Privileged vehicles? Value k helps. It cannot help because in particular k can be n-1, and then it's like this condition doesn't exist. We should indeed investigate always possibility that some condition is there to help, but if k is n-1, which is possible, then this condition disappears. If we have cycle on G without D, then there's oh. If there is a cycle like this, say it doesn't matter what exactly, then because it's a tournament, there is a triangle, right? Let's see, if from C to A, basically any shorter edge, it will give you a shorter cycle, and eventually you will get to size 3. Okay, I agree. So there's this, and now if there is a vertex, it has input degree of 3. No. Okay, well, then Iterin, I again disagree. I agree with this lemma. It's actually well known, and I should have realized that earlier and thought about it. But still, the only thing here is that the vertices from which we can get to D, there cannot be any cycle among them. But still there can be cycle between vertex going into D and some other vertices. Am I right? Like here, I cannot have a cycle here, but if I have a cycle, let's say going through A, E, B, F, A in some order, is there anything wrong about that? G and E connect with BCD. There are edges between all vertices. That's right, if that's your question. Takes more time to load stream in Twitch. You can go watch on YouTube if that's better for you. I can assume that mean degree is greater than 0. I don't gain anything by that. In particular, the graph can be, say, like this, and what do I do? Maybe this lemma actually is useful. If there is a triangle, then let's say we merge it into one vertex. So merge those 3 vertices into one. Then in the remaining graph, if there is a cycle, it means there is also a triangle. So again, we get something. And then there is a condition like yeah, that's That's promising. Let's see, ABC. What we know is that for any fourth vertex here, it's not that all the edges are like that. So either this vertex is strictly before everything, then sure, I don't mind you. Or if it's here, then if there is an edge like that, then there is also an edge coming back, and we have a new triangle. Idea for a lemma: if there is a triangle like that, then everything from, if we can get to some vertex from this triangle ABC, then this vertex is also part of some triangle. Maybe even it is also a part of triangle with ABC. Thank you, Kostka. So maybe the graph will be a bunch of vertices that just go to the right. So they point to the right only with all their edges. And then here we get ABC. And then everything here is in some way interconnected. What is the link to the problem? You can use a command !link to always get it. Let's focus on this part. Also, I think this vertex can exist only if k is exactly n-1. New lemma: if k is not n-1, then every vertex is part of some triangle. Another lemma: if a vertex isn't part of triangle, okay, never mind. But in this prefix in particular, there is this guy, the very first one. Do you mean that there's only one strongly connected component with size greater than 1 with this condition? If this condition is satisfied, then yes, I think there is only one strongly connected component. Maybe I can prove it formally. If there is a cycle here, and there is a cycle here, and all the edges point to the right, then in particular there must be a triangle here. There must be a triangle there. Actually, it doesn't even matter that there is a triangle here. Just from those three, if there are edges to this vertex, from all three vertices, that's done. You cannot have that. So we proved that if there is a cycle, if there is a strongly connected component, and there are edges from it to something else, to some other strongly connected component, then, well, that's impossible, even if this strongly connected component is just of size 1. So we can say only one non-trivial strongly connected component. Trivial means of size 1. Inside this strongly connected component, it seems reasonable to do what I did first, where I started from a triangle ABC and I kept looking at a new vertex. But there might be edges from this vertex to ABC. And can D be still part of some triangle? Well, then no. That's not only about strongly connected components. We cannot. Let's see. If there is triangle ABC, and then there is D. There is here vertex D, such that edges are only like that. Then, if D is part of any triangle, at least triangle disjoint with ABC, then this is contradiction. We cannot have that, because we have here triangle, another triangle, and we already saw that this connection is impossible. Maybe this is valid if we have this triangle. Is this again a contradiction? We cannot. Let's think if is this drawing possible subgraph of something? Well, from yellow triangle we cannot have edges to this guy, which implies that this edge, if this edge goes like that, then this vertex is but vertex D. From yellow triangle, this edge must be like that, because that was a cycle. Then this is bad, so instead, for sure, this must happen. Then this is a new triangle. I'm looking still for a contradiction. This is a triangle, and already it has two edges. No, what am I saying? Oh, it has those two edges. So this last one must go to the right. This is a triangle. Please tell me that there is some contradiction here. It would be so nice. I started from assumption that we have a triangle and another triangle barely touching it. There's just one vertex in common. Actually, mainly I had a condition that this vertex D from it, there are edges to everything in this triangle, but still this D is part of some other yellow triangle. What am I looking at? That's a hard question. Try to figure out the statement thanks to my drawings, just by looking at my drawings. I see a contradiction. From white triangle, there are edges to this guy. There's this yellow also goes to the right. Cool. So this is impossible, which means that this is impossible. This, I mean, it's impossible if white is part of any other triangle. I will write it down. Then white can't, this white for vertex, be part of any other triangle. Or just can't be part of any triangle, not other, because it isn't part of this triangle. Okay, then this is one of vertices in that prefix we discussed here. There was this prefix. So if that's not the case, then always there is a for vertex, and it will create a triangle with this thing. Oh. Now my mouse behaved strangely. There is here this D, and it does it always create just one triangle with those? Say like that, and there is D. Let's think. Say there is this triangle. Oh, then no matter what you do here, it's not, doesn't create another triangle. Okay, so always we get then two triangles in some order. I want to draw all the edges. Four vertices must look like this, and then there is this kind of edge. We don't know how it looks. Cool. Then we have fifth vertex. With green it needs to create one more triangle. With blue it needs to create one more triangle. Does it matter how those two are connected? It seems that it doesn't matter. Let's consider another edge here. So what if it's like that? But we need to have some connection with this guy. It must be with this thing. So that's a possibility. So we now have this triangle. Did we get any contradiction? For sure now this edge is implied because of this triangle looking at this vertex. Is there some introduction to this? You can, I don't know, if you on YouTube search for what is competitive programming, or just in Google, you will find something. What I'm doing is called competitive programming. My stream today is high level. It's not for beginners for sure. I'm analyzing this drawing for any kind of contradiction. How high level? How do I quantify it? Very high. It seems that there is no contradiction here. This is possible, which saddens me, because I hope that maybe we have kind of unique connection now. Atcoder encode versus. You can check. You can open my rating history and check. Now, we investigated being a triangle with this green edge. What if it's with this one? Is that possible? Like that. And then we already satisfy also being connected with this triangle. Does it matter what kind of edge I put here? And also there. It seems that it doesn't matter. From every vertex, all the vertices which are incoming form a DAG. This is necessary condition. Yes, it's necessary. Is it sufficient? I think so. Because if there is a forbidden arrangement of vertices, then there is a vertex such that incoming vertices are not a DAG. Okay, that's an interesting observation, lemma, whatever. Graph is good if and only if graph of incoming it seems crazy to satisfy this. And if we also not allow that, so if we count cases without that fake prefix, then I can also say the same about outcoming vertices. That the graph, also we require that for every vertex, outcoming edges, like vertices to which we can get, they form a DAG. It's some strange condition there, but I guess possible. Let's try to combine it with outcoming. So what if I add this? This is not true in general, but it's true if we ignore that prefix of vertices that only go to the right. No way I stream on Twitch. On YouTube I mentioned that I have Twitch streams. Outgoing, okay. About outgoing condition, about outgoing edges, it's true because of what I said here. I started from this kind of graph where from a vertex there are edges to all three vertices of a triangle, and from this I got, if this white is part of some triangle, then there is contradiction, which means that this cannot be part of triangle or even a cycle. So, and there was a drawing here. No, there can be vertices like that. There can be prefix of vertices such that from there, there are only edges to the right. But now I'm focusing on this real graph, the graph that will be actually one strongly connected component. At the end, I will consider this to be just for smaller n, and then there is this prefix. But if we focus on graphs that are just one strongly connected component, so it's like triangle, where on the top of that you build triangle and so on. Most likely this graph looks a little bit like this. One triangle, maybe another built on the top of that, also with some edges connected to that. No, so strangely looking strongly connected component. But yeah, also there can be a vertex with edges to everything there, and there can be another vertex with edges to everything here, but this will be easy to calculate. So let's instead ignore this thing, and let's just focus on graph being one strongly connected component. And then we have this first sentence, this second sentence, this one. Well, with those two combined, let's look at any vertex. Can I remove this? I think I can. Let's look at some vertex A. There are edges coming out of A, and those, there must be a DAG made of those, so they will be in some order. Say A, B, C, D, and so on. And only edges go down here. Then there are edges coming in. And same stuff. Let's say Z, Y, X. So on, and now there will be edges between those two groups. Between every pair of vertices there is an edge. If there is edge from B to Z, then we have a triangle. But from this triangle there are edges from A to C and from B to C, so there must be an edge like this. That's, I think, very nice. So if there is any edge coming, let's say, from C to Y, it implies also edges from everything below C. But maybe even it will imply more. What about edge from C to Z? Oh, but I said that this is a strongly connected component, so it's not that from Z there are edges to everything. I mean, it's not that, yeah, exactly what I said. So there is at least one edge going from something to Z. And then it's some kind of suffix of this right side of the drawing. I want to take this and make it bigger. All right. Can there be this edge? Maybe in a different color. Is that all right? But then BCZ is a triangle. And I think there is nothing wrong about it. Actually, from C also maybe there is an edge to... no. I mean from Z to C. I think just from Z there will be edges to some prefix of the right side. And then to Z there will be edges from some suffix of this right side. Aren't we looking for graphs that don't contain this structure? Yeah, I'm looking at such graphs. So regarding Masteroy's previous question, I'm counting graphs. I'm counting good graphs, those that do not contain the forbidden substructure. Hamiltonian cycle? I don't think so. But maybe, of course, maybe. No. Am I sure that in the current drawing there is no contradiction? I think this is good. Now, what about Y? Vertex Y. What can be the connections? By the way, I will try to make this drawing with my drawing tablet. Maybe I'm so annoyed today that I cannot draw properly. This is a problem where it's so important to draw. Yeah, still the same issue. I cannot stop drawing. Now we need to think what can be edges from Y to the right hand side. Should it be also any prefix and then the remaining suffix? There is a triangle ZBD. From Z there is an edge to Y, so it cannot happen that from B there is an edge to Y and from D there is an edge to Y. Same if we look at triangle CDY. It cannot happen that from D there is an edge to Y and from B there is an edge to Y. It cannot happen that from both D and C there is an edge to Y. So the red must be only lower. I think that now for Y the split will be like this, let's say, maybe even a tie, the same kind of split, maybe like this, and then the red will be remaining. So if previously for Z this was the split bar, then for Y this is the split bar. It cannot be higher, because then CD would both point to Y and ZCD would all point to Y. That's forbidden. For every next vertex here, the split on the right needs to be lower. Spexy, I used my drawing tablet for a year now. I'm aware of hovering. It's broken. It works in a different way that it worked a week ago. I worked for hundreds of hours with my drawing tablet and it just broke. Something is wrong. But thank you for help. Yeah, I'm aware of hovering. When I hover, it thinks already that there is some pressure. It detects it as 20% pressure, and my software doesn't allow me to set some pressure threshold, but that would help. If I could set up that only if I press with at least 30%, then detect this as drawing, that would help. If there's that kind of software. But my Wacom drivers, they don't support that. What are we doing here? If what I said is enough, then I can look at any vertex. I can iterate over size of both sides. I can iterate over how many vertices will point into A. There is some binomial coefficient here, sure. And then for each of those, I need to choose an element here, and they need to be sorted. And that's some binomial coefficients again. Oh, sorry. When I split into two groups, it's not just binomial coefficient to say that there are elements on the left, on the left and on the right, because the order matters too. So I think for A, there is n-1 factorial ways to split. n-1 factorial ways to order all the vertices other than A, and then we need to split them into two groups. And the number of ways for that is n-2. If you have the sequence of n-1 elements, this is the number of ways to split them into two non-empty sequences. And this is the number of ways to order them. Right now I have order ZYX, BCD. And then I split them between X and B. And this. And but actually I think I will iterate over the size of left side. So it's not that I will get one concise formula. We'll iterate over this, and then I know what's the size of this, size of that, and there will be some formula to say what's the number of possible connections. Now, can it happen that Z will be connected with everything on the right? No, because then Z is that special vertex. Actually, maybe I should allow that. If for Z everything on the right will be green, then Z is basically one of those, one of this prefix, actually the very first vertex. For now, let's say that that's not allowed. Can it happen that for X, everything on the right will be green? So I have edges there, but from something there, in particular from the last guy here, there is an edge to Z, and then from that there is an edge to X. I think that's illegal. So green on the right expands and expands. I just don't want to count away where from Z I have all the edges to that. Okay. Online course from Udemy. Machine learning / data science. It seems that you're asking about two completely different topics. Then maybe you need to first research what you want to learn. And I don't think you will not find a machine learning expert in me. How do I remove this dot? Here you go. Okay. I'm thinking the whole time whether we need to check something more there. Not check, we need to guarantee something, and then it will be more complicated than just some formulas. No. If there are L elements on the left and then R elements on the right, what's the number of possible connections? It will be something like this, with off by 1 mistakes. For L equal to 1, assuming that green can take everything as well. For L equal to 1, that's correct. For L equal to 2, this is R plus 2 times R plus 1 over 2. Is that correct? Why R plus 2? Oh, because it's R plus 1 choose 2, and also there is possibility of a tie. Yeah, okay, I think this is it. It's this minus the case where Z is all green. Do you consider live streaming on YouTube? I am live streaming on YouTube. This is the link. I'm double streaming to Twitch and YouTube. The YouTube is mainly for two reasons. One, and the main reason is that then it's automatically recorded, so I don't need to bother recording and then uploading a big file. And the second reason is that for some people Twitch doesn't work well, and then you can switch to YouTube. You can watch on YouTube. In particular on YouTube, it's easier to rewind, speed up, change the quality. Actually, is it? I want to check. It doesn't. Yeah, there are options of quality from 1080p all the way down to 144. Well, that's not very. You don't see a lot here. This is 144p. Well, the drawing is kind of readable. Alright, then we iterate over the size of L. So it will be for L from 1 to n minus 2. L is size of the left side. That's it. And this will be the number of the. Do we have a sample where k is equal to n minus 1? We do. We do have such a sample. Let's try to get this answer. It will not be easy, because I need to also consider the prefix. Do I want to do this on paper or just implement a solution? Let's do it on paper, because most likely it will not work, and then I can fix it. If L is 1, then we have n, by the way, n equal to 4, k equal to 3. For L equal to 1, answer plus equal 3 factorial, that's 6. Those are binomial coefficients. That's 6 times R is n minus 1 minus 1, 2. Free, choose 1. That's 3. Minus 1, that's 2. So 12. This is symmetrical. In total, we already got 24. But those are ways where the whole graph is one strongly connected component. Then, what about cases where there is A, and then like one vertex, let's say V, and then there is strongly connected component? I'm afraid that we will get too small answer. Those values are too small. We will not get 56. But let's try. Then from this, there are 4 ways to choose V, and then we need to build strongly connected component on 3 vertices. Well, this must be a triangle, so actually I know that there are 2 ways. But let's see if the method would work. L would be 1, so we would have here for n equal to 3. This is 2, multiplied by 2 minus 1, 1. So this is 2. Then this is 2 again. Okay, it works. Then there are cases where there are 2 vertices and then strongly connected component. That's impossible. And there is also a case like this one. And that's 4 factorial. That's 24. And we got 12 plus 12 plus 8 plus 24. 56. Not that working for n equal to 4 means a lot. It's a very small test. But it's promising. How would you do it? I don't know. I think that starting with Python is the safest. Bogita. So maybe you can read about it. If you Google what language to start with or something like that, how to start with programming, there will be thousands of articles. Learn Python. Find some free Python course. That's a good start. Now, what I'm going to do is I'm going to implement this for K. I can either now think what happens exactly about the condition with K, or alternatively, I can implement this for K equal to n minus 1, grab somebody's code from submissions in order to be able to run something for n equal to 10, for example, K equal to 9, and then I will check if my solution works. And I think I will do that. I couldn't do it during a contest, but it's not a contest right now. I know that I wouldn't solve this during a contest anyway, so why bother simulating contest conditions? Instead of grabbing submission of somebody else, I can implement a brute force, but I'm too lazy. What would that change if you get a job? Would what change? If I get a job in this field ASAP. But what would change? Python? Oh, you mean you want to get a job quickly? What to learn? I don't know. There are some bootcamps and they teach strange languages or technologies like Ruby on Rails. So maybe if you want to get a job in 3 months, Python is not the best. I don't know. 6, 7, no need to repeat comments. Sometimes I skip comments on purpose because I just don't know what to recommend. Okay, then let's implement this thing. For K equal to n minus 1, because I want to make sure that this works. before I move to various k. But for smaller k, I believe that we cannot have that prefix, so it will be simpler maybe in some way. There will be condition for the size of left part, because a input degree cannot be too big. And for everything on the right, there is limit for input degree again. So it basically boils down to b. Because other than very special case, if everything here is red, then input degree of b is just everything on the left and a. We will only need to be careful about input degree of a and b. That should be easy to handle. What did I do? Will I need inverse factorials? Well, I will need that. N is very small. Why is n very small? Oh no. If n is very small, it means that the remaining problem is difficult, because for now I have like linear solution. And this will be quadratic. And k for some reason is at least a half, and also I will need to use this. Or maybe this is because otherwise trivially that's impossible. Oh yeah, okay, never mind this. Or should I? If input degree must be half of n in some case. Alright, so this never mind. But small n scares me. Let's implement some basic functions. We have modular inverse. I want factorials and inverse factorials to have access to binomial coefficient. I'm stupid. Because of n is small, I can just compute them brutally. Then likely this is unnecessary. Binomial coefficients done. Still need factorials. And now, what do we do? We iterate over the number of vertices in the prefix, and then the rest will be SCC. There is some number of ways to choose vertices for prefix, and then what happens with SCC? Let's focus on SCC first. Assuming that I already let's assume that there is nothing else, there is just SCC. Then we iterate over how many vertices will go to the left of A. A is just the first vertex available. Like that. And now formula from the drawing. This thing, can I copy? I can. I wonder if this... Can this be divisible by mod? It can't. So I don't need to here add module. Interesting. Binomial coefficients aren't random values. They are very special and they cannot be divisible by big integers, big prime integers. That's useful. We have weights, then we focus on the prefix. (32). I missed something, but maybe it will be easy to see what I missed. 32 seems to be 24 plus 8. So maybe I didn't handle prefix equal to 0. No, for 4 I did something wrong. Right. What about now? It worked. But I really want it to work here. So let's grab somebody's code. Five, 4, 4. Easy. Okay. My solution works for k equal to n minus 1. And now, what do we do after that? Well, we care about input degree of A and of B, and we also keep in mind that there is that prefix, and prefix points down to everything here. Oh, I said back then that this is possible only for k equal to n minus 1. That's not true. I mistaken out degree with in degree. PC gear. I wonder if I have a command like that. There should be one. For sure, you will find my hardware information here in FAQ. Yeah, I think so. All right. So if everything is red, where's my code? Here. If SCC is 0, only if k is equal to n minus 1, we should do this. This special case where there is no strongly connected component. I mean, there is no non-trivial cycles. Then for all the other cases, there is a if prefix plus L is greater than k, then continue. What about B? B can have bigger by 1 input degree. So if prefix plus L is equal k, then A is just barely making the cut, but then B on the drawing must be in at least one red. Otherwise, its input degree is too big. Okay, then we know that for Z we need to choose just the whole red, and then we have some choices after that. This will change. Instead of L, we will use L minus 1. Right? Nope. Something is wrong. This should count a cycle. Why do I say 0? For prefix equal to 0, you should split into L and R. L is 1, R is 1. What 1 do I subtract here? This is the case where everything is red or everything is green, I think. What is that? One of those two. And if this is the case, then we shouldn't subtract. Maybe be at least one red. Will it work now? Worked here. Okay, 4 to 4, 4 to 4, 4 to 4. Very nice PC. Well, thank you. I use PC for work, so I bought a good PC. Should you be able to implement all the DSAs before trying to solve problems? No, of course not. I have a video on how to start with competitive programming, and the video says you should solve problems. And as you solve problems and read solutions, you will learn everything needed. My answer is much bigger than it should be. By 2000. In particular, it means, like this is the same test, yeah, same test. In particular, it means that this is incorrectly computed. Most likely, this is incorrectly computed too. If this is greater, then it's bad. If it's equal, then B cannot get this one extra edge. It cannot be true that all of them point to B. So they include B in their thing. This subtracts L by 1. Because Z need to be all red. We don't have a choice. We just have a choice for the remaining L-1 elements. And what did I subtract here? I think what's bad is if everything on the right is green. Because then everything is DAG. But if Z is all red, then there is no need to subtract. Yeah, this seems fine. ICPC marathon, what would that be? I participated in long contests, but just solving standard problems for 24 hours would be very boring and also exhausting. Learn algorithms, solve problems. You can watch my how to start video, how to start with competitive programming video. I need to make a link for that. So wait a second. Too many people ask me this. Okay, so if you watch, then why are you asking? It's not that I hid some tricks that I could put otherwise in the video. Hello everyone. Okay, if anybody asks like how to start with competitive programming or algorithms, please use the command start to tell them. If they ask how to start with programming, you know, like independent from CP, that's something else, then I would recommend Python. Please somebody tell me why this is wrong. And actually I believe this is wrong because limit for n is just 200. So the intended solution for sure is slower than my n square. Also I saw that tourist submission takes 2 seconds. So it's like n fourth. So I'm missing something big here. My day was fine, thank you. Quick recap. Oh. Okay, we figured that for every vertex, we need to count graphs of some type. For every vertex, there are vertices, and this is tournament, so every pair of vertices is connected. We can look at any vertex and its input edges, so this part of the graph, it's a DAG, directed acyclic graph. So let's say that it's in order z, y, x, and so on. Also, this is non-empty. Then vertices to which you can get from A, I mean vertices that are at the end of edges going out of A. This is also a DAG, or at least I'm focusing on counting those cases. And then there must be special kind of edges between left and right part of the graph. What kind? From Z, there are edges to some green prefix of the right side, and then edges out of red suffix of this. And then for Y, the split into green and red need to be same or lower. So if for Z, green prefix was BC, then for Y, green prefix must be BC or BCD or BCD something, and so on. But then there is also, well, the prefix means that also there are edges, extra vertices, such that from them there are edges to everything in this graph. Those edges, they form some kind of prefix of the graph, while this thing, it contains cycles. And there is also limit k, limit for input degree. And now I need to take care of that. Without k, my program works. If there is no limit for input degree, my program works. Now, I thought that limit for input degree matters only for A and for B. But apparently that's not true, and I'm investigating. Or maybe I handled it wrong. N is 6, L is 2, then R is equal to 3. And we got here a lot, by more than 1,000. 2, 3. But for a limit of... Oh, there are edges going down here. B is not the worst. Of course not. There are edges going down here. I forgot about them. I forgot about this edge, for example, this thing. It makes the degree of those guys to be big. Well, I'm happy I found the mistake, but I'm unhappy that it is something that is not trivial to handle. For sure we need now DP or I don't know, maybe DP. Okay, let's look at yellow splits. DP will be based on left prefix, right prefix. This right prefix, it means that the last thing from the left, it reached up to this place in the right part. And everything was valid so far, I guess. And maybe if I reached up to this yellow spot, then I need to know the input degree already of that vertex. That's solvable for sure in polynomial time. Let's see what can we do. There is prefix here. We iterate over L and R. But if I have this and that, then I can only have n square here inside. That's for sure not like this. Maybe DP should be independent on L. Or maybe it should be dependent on the sum L plus prefix. No. On just the prefix. Because prefix kind of decreases K. So right here, before iterating over L, I will do DP, and then it can be cubic. Still with those, it seems that I need linear transitions. Maybe I should say that it's like that. And I'm forbidden to again have a split here. So yellow is here, yellow is L prefix, this is R prefix, and then the next element here, it will reach to something below R prefix, and some consecutive elements will do that too. Do it linearly, maybe. I will need to iterate over how many elements now will use the same split. And depending on that, it's allowed or not. So from this, there is transition for free here, which just means I'm skipping this next element. I'm not using this as a split. And then also I can iterate over how many consecutive values on the left, let's say X, they use the same prefix. And this, like, it increases its degree by a lot, actually in both cases. This can be even done in constant transition time. Just it would add another dimension that tells me if now I move through the right part or the left part. Oops. All those splits, they actually can be represented as a grid, two-dimensional grid L by R, and a path between corners. It corresponds to the way to assign splits. And there are some conditions, like whenever you go down in column C, you need to be that high. And I think even constant transitions are fine. Good sites with problem along with proof of solution. By default, let's say that all platforms do that. Topcoder, Codeforces, Atcoder, CodeChef, they should all provide proof of a solution. With this interpretation, it's like we decide so we're aiming for this. And it will be maybe without that. Yeah, no, without that. We have those two transitions. Whenever I move the left split by 1, it just means that I used this connection. But it means that Y uses that many green. But I don't know D was in how many greens already. Maybe I should move backwards. Worth to give years of life to become IGM? Only if you like it. If you don't like it, then nope, it's not worth it. If you like it, then, you know, just do it because you enjoy it. What I don't like about my Atcoder streams, by the way, is that they can get very long, and I can try to plan my stream for, say, hour and a half. That will be maybe perfect for me. I don't want 5-hour streams. Also because it just then hard to talk for so much time. But with those problems, how can you make it shorter than 2 hours? Hydrate. Did I hydrate before seeing your comment? I mean, before you wrote the comment, or after? I think it makes sense to go backwards. So let's start with yellow split here and there. Actually, should I make a new drawing? Because this one is a bit chaotic. XYZ. VW, what is here? Alphabet backwards isn't easy. Of course, I'm wasting time now, it's not important. And A, B, C, D, E. Let's say like that. A actually is reserved, so let's not use it. We start like that. Wrote it before you drank, so then I didn't even need to look at the chat to get that you wrote it. Video on linked trees. No, I'm not an expert at linked trees. You love long streams? I don't know, people come and go, you know, it's hard. I'm sure it's hard for many viewers to find time for a 3-hour sitting and also to stay focused. Shorter chunks are better. How many people right now, they can say they watched from the start for the past 2 hours and they stay focused? Maybe like 20% at most, I would guess. The drawing software is OneNote. If I move up here, that doesn't mean a lot. But if I move with this guy, all green, like that or shorter. What about this? No, that's stupid. I'm not sure now if I'm thinking about something easy or not. If X uses D, then it means that D is included in X, V, and W. Previously, maybe Y used D, and then it means that D was used by Y, X, V, W. Okay. Then we what does it mean that we put a split here? It means that we increase inputs for input degrees for those. In particular, we can increase only up to there, or up to here, here, and so on. So initially, this is a candidate. If we then move to that state, it means that we didn't decide yet. Keep moving, and let's say we want to use this kind of split. Then we need to check if B and C are good. Basically, we need to check if C is good. Let's say much later. I used this split, then I'm looking at V here. X already guaranteed that D is good. Now V can either repeat this, and when we really use this, then we say XVW are used for those three. So we are looking at D and we are thinking whether this is for sure safe, because now D has edges like that from B, from C, from A, from the prefix, and also from those. At this point we check if D is valid or not. Why isn't there an option to support me? There is. It's called watching the stream. I'm doing fine in my life financially. So I don't need donations. People leave, I'm now reading past comments, people leave shorter streams too. I don't think that is a valid reason. The most important thing is whether something is split into short chunks or not. 5-hour stream would be better. I mean, maybe this. 5-hour stream where I just solve one problem and you need to understand what was happening from the very beginning is very bad. Because if you join in the middle of a stream, it's hard for you to catch up. If, let's say, I solve lead code problems and every 30 minutes I switch to a new problem, it's much easier to focus on something, and it's much easier to join the stream. So it's not really that the issue is with difficulty of a problem, because, well, some people will want this difficulty, some people will want another. Of course, more people would watch easier stuff. But the biggest issue here is that what if you are strong, you are able to understand this, but you join after 1 hour and you don't have all that thought process that happened already. And sometimes it's hard for me to, I want every 10 minutes I cannot again make a summary of what happened. And sometimes it's very hard to do such a summary. Also, I think if you spend 5 hours watching a stream, even if it's my cool stream, if you're not doing anything else in that time, you're not spending your time efficiently. If you watch my stream for 2 hours, you will learn something. If you watch it for 5 hours, come on, that's half of a day. It's better if you solve problems yourself. Because watching somebody else to solve problems is less valuable in the long run. Than solving problems yourself. You shouldn't just watch other people code. That's extremely important in programming. Okay, so we have here this, that. I think that this drawing is enough for me now. And because it's quadratic, I can put it there. Yeah, I will put it here. Now this condition isn't important at all. This is what we had earlier, and it worked for k equal to n minus 1. Then we're looking at I here. Now j equal to 0 should mean this guy, j equal to 1 should mean this one. Fine. What choice do I have? I can move by 1 like this. And I should do nothing then. And if something is satisfied, then I can move to this state. This is j equal to 0. Before that, you can also split after this, then everything is green. There are possible slots. Then if j is not r, then we can move forward on the right. Otherwise do this. Also the answer will be the sum of dp of L. We will also need to check G. Maybe not. That, and now what's left is the if. What's wrong? When I connect x with d, this is what? Equal to 0, 1, 2, 0, 1, 2, 3. Then what is the deal with this guy? Well, L minus I says how many things we have here. What's the input degree of the prefix plus L minus I? This is L is 5, I is 2, and this is 3, okay? Plus 1, because there is this middle vertex A somewhere here. Plus B and C, this is J minus 1. If this doesn't exceed K, then we add. Nope. And the answer is too small, so sometimes I'm forbidding a situation that actually should be allowed. If I did this, then it would be too big, right? Yeah. Add self works. Works. Is the word tournament a specific term in graph theory? Yes, it is. If you Google tournament graph theory, there should be entry on Wikipedia. Tournament basically means that you can compare every two elements, let's say. Maybe that's a stupid definition. Forget about what I said. There is a directed edge between every pair of vertices. That's tournament in graphs. Here I'm not checking anything. That's right. Then prefix plus L minus I. For example, here I is 2, L is 5, so I'm taking 3. Because X will have green there, V will have green here as well, W same. I shouldn't check this if J is 0 though. I don't know if that matters. '67 again, nothing changed. Because if F is 0, then there is no here guy above. 1, 2, 3. Prefix plus L minus I plus 1 plus J minus 1. It looks good. Don't I need combinations? Oh, I need this. I still need to order them. Wait. So what was here? I reordered all SCC minus 1. And this was to choose. So this is part I'm computing there. This is the number of ways to choose splits. Still, it should be multiplied by factorial of number of vertices. Not quite there, but now at least the magnitude is right. And it's already too much here for the very first case where prefix is 0, so it's not a mistake with prefix. Like for prefix 0 already I have two big answers. Let's check G as well. That's closer. Am I right here? G, what entry, what are in edges? Everything from prefix, the middle guy, and everything above me. Cool. Maybe here we will hit G as well. If something points to just below G, then it means that green contains G. But maybe not. Okay. In degrees of those. Input degrees of those are smaller than input degrees degree of the middle guy here. This thing checks if the middle vertex here A, it has proper input degree, and those have only smaller. That's not true. There are edges from the right to the left. Hi, Anand. You're quite late, so You're I would say we're already in the middle of solving the problem. Hello, Deja. Come on, why there are input degrees for vertices in the left? That's so unfair. If so whenever I connect Z to something, okay, then maybe this is alright, and I just need an if. If this what's input degree of vertex I? Well, that's prefix plus I, vertices above me, plus R minus J. R minus J. 1104. Submit. I have some CRR. Why Control F doesn't work? Or maybe it's outside of this. Well, this is not, doesn't slow the program down. Thank you, Eric, for good observations in this second half. I didn't pass the sample test. I didn't pass the first sample test. Well, this is the one with k equal to n minus 1. Now, do I make an if, and if k is equal to n minus 1, I do the, this thing? Maybe all those tests where it doesn't work are exactly like that. That would be unusual. Okay, easy. What can I do? Apparently DP doesn't work for k equal to n minus 1. So and I double count. The answer was too big. Do you guys think that we need a centralized institution that manages the ratings? I think it would be nice. I think there should be something like that. It would help competitive programming in general. There would be issues with that, but the advantages outweigh the issues. So I would say, yes, there should be something like that. I agree that contests aren't the same, but still... And there would be so many arguments, like so much arguing. And the only institutions I think that can start doing it really officially are, I don't know, ICPC organizers. They are big. Codeforces doesn't really have that power. Why should Mike decide about it? Maybe there should be some kind of committee. But I would say there should be something like that. Just, it would be, some committee would need to sit down and decide which contests are taken into account. In particular, do we count some contests where not that many people participate, like, say, Hacker Earth? Their contests are open, and I don't think they have a lot of issues, so should we consider them or not? Maybe with some small weight? I don't know how it's computed in chess or tennis, where is every match equally important? Why do I double count? K equal to n-1. So this is correct, this is wrong. This cannot happen if k is n-1. What about this? I can say what this is. Okay, already for 3.2, my code is incorrect. I can try 2.1, but I doubt that this makes any sense. Yeah, nothing is here checked meaningfully. All right, this is a counter test, where if I have one element on the left, one on the right, there should be one possible split. Why? Because well, 2 is the number of ways to choose. Okay, we have 3 vertices. I choose something in the middle as A. Then there are 2 ways to say which one goes to the left, which one goes to the left, and which one to the right. Let's say like this. I know that there are edges like that. And if there is just an edge from left to right, I see. The issue with that is that that's double counted, because then we don't really have a triangle. So I should subtract that case where everything goes to the right. In this case, I don't want a case where everything was green. Not enough? Oh, but it's here. The style is now very bad, but at least I understood what's the issue. Let's see now. This is without that previous special if for k equal to n minus 1. Because this thing was with an if, and I didn't know why something works like that. Cool. Works, and also it's quite fast. And I won't be surprised if this can be pre-computed before else. Nah, like it can't. Okay, it's just 2/4 power. All right. 2 hours and 24 minutes. A lot of help from the chat, but I didn't look at the editorial, so still it's some kind of success. Step 1, 2, 3, 4, 5, 6, and then the algorithm. Let y be the set of vertices such that the edge this exists. The others number vertices in one part. K by L grid. Yeah, and there it's like a path through a grid. Okay, I don't want to read everything here in details, but at the end we did the same. There is that DP, we chose arbitrary vertex, so it seems that the solution is at least very similar, maybe the same. I hope it's already registered. Nice. Atcoder Grand Contest 46 fully solved. 50 more contests to go. Fewer than 50. Solid 1v1 format in CP. Is lockout solid 1v1 format? I think it's as entertaining as we can make it. Have I tried investing or trading in crypto? I would say it's investing or speculating / gambling in crypto. I think that most of cryptocurrencies are pretty bad, like including Bitcoin, where the transaction fee is very big. It's not really that private. Like some people want to use coins because they don't want government knowing about their transactions or something. But the transactions are pretty public. Miners use a lot of power, so if I had a possibility to destroy Bitcoin completely, I would. I think it's bad. Doesn't mean that I don't own Bitcoin. That's another thing. I don't, by the way. By the way, I don't recommend trading or anything like that. You compete with companies who have a lot of resources. They spend years improving their algorithms. Why would you beat them? So don't waste your time and money on trading. All right. And I'm saying it as a guy who worked as an intern in such a company. Thank you all for watching. I'm happy after solving this. We see each other on this Sunday, I think. So I'm trying to switch from Saturdays to Sundays. And next week, I'm not sure about my schedule. We'll see. But I think 1 week and 2 days from now, there is Code Jam Round 3. Yep, 9 days from now. Maybe this weekend, instead of interviews, what I will do is I will take some old Code Jam Round 3 and I will go through that. That might be a good idea. I think this Sunday I will do that. Yep. Problem versus question. Didn't I say what I think in code versus already? Questions and problems mean the same thing, so whatever. That's my opinion. I prefer problems, but because of my streams, I'm used to questions. In particular, interview questions. People say interview questions. And I said here that I gave a contest is something I hate. I used to work in finance. Not really. It was just as an intern in high-frequency trading company. I also studied economics for 1 year, but believe it or not, it was too easy. At least the faculty and the exact field I chose. Maybe it was a mistake to first learn a lot of math and then go study economics, because then economics is just trivial and you get bored. Oh, what is your opinion about this and what you pointed to this exact comment? Oh, by Anand. Radeusz, I mean, he doesn't like some word, so he points that out. There's nothing wrong about it. Maybe people care more about it because he's high rated, so people actually notice that. If let's imagine that I keep saying that I hate geometry. Does it really matter if I say that 5 times? So what? Apparently I don't like it and I want setters to use other topics. 3-person lesson groups suitable for coding interview prep? Yes, if I find 3 people willing to learn for interviews and they have similar skill level, then sure. I'm not into research, no. All right, thank you for watching, bye-bye. And hooray, I solved F without editorial, only with help from the chat. See ya.